our group for collaboration, we all went to Zoa's house, who was really excited to see us. Someone would bring up an idea and explain the concept, and the others would listen and give their feedback.
So we first decided as a group that we would be designing for a commercial green skyscraper, maybe in downtown Vancouver, as it's an area that would benefit from green technology and green innovations, as it's a highly populated area in the heart of BC. And given our understanding of the local climate and weather conditions, we're better able to plan for the local conditions and adapt our green ideas to fit Vancouver. Then we did some research and looked into multiple sources detailing green technology, how it worked, and the principles they were based on.
For example, we looked at innovations in building materials, building design, and building use, such as using low VOC paint, recycled forestry products, water collection systems, and the zero energy concept of building design, which is the idea that the net energy of a building usage should be zero. It provides its own energy and is self-sustaining. Ideas were further divided by category into the physical, chemical, and biological perspectives, and we'll be presenting the best ideas from those categories in our later videos. We had a great time doing this and have a better appreciation for green technology.
Okay, so geothermal heating is an efficient renewable energy resource that taps into the Earth's natural energy to generate power. You might think that cold weather would make geothermal heating ineffective, but that's actually not the case because the pipes escape the effects of the freezing temperatures. The ground actually stays close to 60 degrees Fahrenheit around there, and it makes a warm source of energy in the winter and a cool source in the summer. A water antifreeze mixture is basically pumped through the pipes buried underground to collect thermal energy, then routed to a heat pump that takes the energy to either heat or cool the building. While it does take energy to power the heat pump, the efficiency of the geothermal system means that far more energy is actually gained than invested. Although geothermal heating does have its disadvantages, digging up ground space to lay up piping is a huge undertaking. It is still a viable natural resource. Then we have the electrochromic smart glass. So smart glass or electrochromic glass uses a tiny burst of electricity to charge ions on a window layer and change the amount of light it reflects. While low emits windows that block some of the light's radiation already exist, smart glass gives you the ability to choose how much light you want to block. If you tie this into smart building control systems, skyscrapers could have thousands of windows that tilt automatically during peak hours and return to complete transparency in the evenings, which saves a lot of energy. And smart glass developers expect a 25% reduction in HVAC costs thanks to these dynamic windows.
The first biological aspect of a green building is to have a compost system. We found EarthFlow, a composting technology that works well with large organizations such as university campuses, or in our case, a large commercial high-rise. It's an in-vessel machine that features automated mixing, aeration, and water addition, so it requires very little labor. It can receive a lot of waste, which is perfect for a large company. It prevents odors, and its rich compost can be used for gardens on the roof and throughout the building. The second biological aspect is to install green walls throughout the building. The green walls inside not only beautify the interior spaces, but improve air quality by filtering and absorbing toxins such as VOCs and formaldehyde, as well as producing oxygen. Research shows that indoor air can be up to 10 times more polluted than the outdoors because of the materials used to construct the buildings. Since people who work in the high-rise spend hours there every day, we figured that this is an important part to have clean air quality in the building.
Chemistry perspective, I looked at zero VOC paint in terms of how that can make our building more environmentally friendly and clean. So what are VOCs? They stand for volatile organic compounds, which are organic chemical compounds that are released by numerous sources. In this case, we're concerned with conventional paints. And these VOCs can have numerous health and environmental effects. Some of the health effects can include dizziness, headaches, and memory impairment. With long-term effects being difficult to quantify in humans, but having been linked to cancer in other animals. And these VOCs are emitted over long periods of time. So even after the paint has been applied, years later, they're still being released into the air by the products in the paint. And the quantities of VOC are so significant that inside a household, it's 2 to 5 times more concentrated than the air outside. The paint we would be using would have zero amounts of VOC and allow the air inside our building to be much cleaner than it would be using conventional paints. Also, with no VOC being emitted by the paint, it would be less of a burden on any air filtration systems that the buildings might be using. Thank you.